Hello, Chipstrat listeners. Today we're talking with Jared O'Leary, co-founder and CEO of SirenOpt, a company transforming manufacturing intelligence with a novel form of metrology that uses cold atmospheric plasma, sensors, and machine learning. SirenOpt is helping manufacturers measure the unmeasurable, reducing waste, improving product quality, and redefining what's possible in advanced materials production. So hello, Jared, welcome. So first question for you, will you tell our listeners a little bit about you?
Yeah, sure. I co-founded SirenOpt in August of 2022 with my former PhD advisor based on my PhD research over at UC Berkeley in the chemical engineering department. Before that, I did my undergrad over at Stanford, also in chemical engineering. Between Stanford and Berkeley, I worked in industry for a few years.
Oh, nice. Okay, cool. So tell me, how did you land on your plasma sensing during PhD work?
Yeah, so my PhD broadly focused on sort of characterizing, modeling, and controlling what can be labeled as intrinsically stochastic systems with nonlinear dynamics. So basically systems that sort of evolve probabilistically and nonlinearly. And my PhD was almost entirely computational, right? It was really about developing computational tools, sort of characterize, model, and control these types of systems. And we looked at a lot of different systems during my PhD, right? Including systems for semiconductor manufacturing, including systems for colloidal self-assembly, if anyone's ever heard of that. And, towards the end of my PhD, I started briefly looking into sort of these systems of cold atmospheric plasmas, right? And really we were interested in, characterizing plasma material interactions. And then, as a second step, really trying to develop advanced feedback control algorithms to control those plasma material interactions. And we were really looking at cold atmospheric pressure plasmas, in the context of treatment. So really in the context of treating skin tumors and, things of that sort, right? And, over the course of this research, right? And, I think at this point it's probably reasonable for me to define what a cold atmospheric plasma is.
Yeah,
right?
sure. Totally. Yes.
But cold atmospheric plasma, is basically an atmospheric pressure, weakly ionized gas that sits at about 40 degrees Celsius. Plasmas in general are considered the fourth state of matter, right? So lightning is a plasma, the stars are made of plasmas, etc. And we're basically looking at a cold atmospheric pressure version of that. So, anyways, when we were looking at these cold atmospheric plasmas in these treatment applications, we realized two things. One, that the feedback control algorithms that we developed could actually create a very, very consistent plasma. Then second, we realized we could create and maintain a very consistent plasma at a very, very low energy, which then basically allowed these plasmas to interact with materials in a sort of non-destructive manner, right? And then once we made that realization, we knew that there was a lot of information in the resulting plasma material interactions, and we knew we had the sort of machine learning expertise to extract that useful information out of those interactions. So we really just thought, well, hey, maybe this could be a sensor. Maybe this could be a non-destructive, metrology instrument, right? And because of a lot of our familiarity with sort of controlling advanced processes and advanced manufacturing processes, we intimately understood how often these advanced processes are sort of limited by, a lack of information. So we thought, hey, maybe this could be a sensor or a metrology tool. We knew, hey, broadly this might be important. So let's just run a few experiments and see what we see, right? And then we ran a few just quick little dumb proof of concept experiments, right, that showed, okay, I think this actually could be a sensor. And after doing that, we then had to ask the question, right? Okay, well, would anyone use this? How valuable is this? What types of industries would maybe want to use the future version of this type of tool. And luckily we're in the Bay Area, and there's lots of battery startup companies and all sorts of interesting research around, and we talked to a few companies who had a lot of manufacturing challenges that we felt we could solve. And that was enough for my former PhD advisor and I to say, hey, you know what? Let's we like working with each other. Let's try and start this company.
Nice. I love it. That's awesome. Yeah, you're in the right area for that. So it sounds like, so you started more kind of on the computational side and then eventually started experimenting with like, oh, could we actually physically make a system to do this? And then you started looking at like what are the applications. And by the way, you said you landed on cold atmospheric plasma, and you mentioned that it's like cold is in like not super high temp, like lightning or something, and atmospheric, so not like super low pressure, super high pressure, but just like normal pressures. And so that I assume that means it's amenable to manufacturing because you don't have to have like a high power or expensive system.
So,
or correct me if I'm wrong there.
yeah. So yeah, let's be like precise here, right? So,
Yeah.
the primary benefits of the plasma being, cold, where cold is defined as below 40 degrees Celsius, right? And like atmospheric pressure, right? Is that one, it can, be in like you said, right? This type of system can easily be placed in a lot of different types of manufacturing systems, right? There's not, so, when you say, hey, it's, this thing is not necessarily expensive, well, it's like, let's talk about what expensive really means, right? Like, this does not require some extremely fancy setup, right?
Yeah.
So, right? So, this is something, really that, we believe can be, pretty easily integrated into high volume manufacturing workflows. And, another, benefit of the, low energy or lack of temperature, coldness, for lack of a better term, right, is that, really the plasmas can be very gentle, right? And they can, really interact with materials sort of non-destructively, right?
That's right. Yeah. So non-destructive. So presumably that means you could do like inline sensing.
Exactly.
Gotcha.
Right? That's really the goal of where we're going here, right? And that inline sensing, the two key aspects of that is like, can you be non-destructive? Can you measure fast enough, right? And can you actually be integrated into a high volume manufacturing workflow in a reasonably easy way, right? And we believe our system meets all of those key requirements.
Nice. So tell me, for a given industry, if your system is inline, so you've got the plasma and you're sort of gently interacting with the material, and then you're measuring some sort of interaction, like what measurements are you making?
Yeah, great question. So let's answer this in two stages, right? So the first stage I think is important is, we say, okay, there's these plasma material interactions and they're informative. Well, okay, how do we record them? What does that mean?
Yeah.
Right. And so, the types of interactions that we have or that we induce are basically these sort of synergistic thermal, electrical, and chemical plasma material interactions, right? So you actually have something very interesting in our system, right? Which is that as the plasma interacts with the material responds to the plasma, and the plasma responds to the material. So you end up with sort of a lot going on. And then so our system has, detectors inside of it that are directly meant to record these sort of synergistic thermal, electrical, and chemical interactions. Right. So our system contains like an optical emission spectrometer. It contains a high-resolution thermal camera, right? And it contains a variety of electrical probes, right? And the detectors it contains right now are by no means the final set of detectors that this platform will ever have, right? In fact, like an active area of research for us is seeing which new or additional detectors we can add, right? But at least for right now, we have these sort of three classes of main detectors. And then so the platform records all of this raw data, right? Which, really like right now is like 213,000 data points per measurement, right?
Wow.
And that raw data itself can be physically meaningful and can be informative. Like certain peaks in the optical emission spectrum mean certain things physically. Certain electrical signals mean certain things physically. Certain, if you look at the thermal image and how like heat diffuses over the thermal image, right? That means something physically. But really, for a lot of advanced manufacturing processes, right? A lot of people care about certain types of properties. What our platform does is it basically takes all this raw data and it feeds it through a computationally cheap physics-informed machine learning model. And when I say machine learning, I don't mean fancy neural network or anything like that. I mean pretty simple, computationally cheap, vaguely, nonlinear model here. that then is calibrated with a handful of reference measurements in order to translate all that raw data to properties such as thickness or density or resistivity or chemical composition, etc. Now, our primary benefit here, right, is that the platform can simultaneously output multiple critical material properties at once. Right. So right now, certain properties for a lot of industries are very commonly measured inside of manufacturing lines. So for example, thickness is very commonly measured inside of manufacturing lines. And so we're not coming over here trying to be a better thickness sensor or measure thickness better than anyone, etc. We're coming over saying, hey, yeah, we can get things like thickness, but we can also get these other properties like, the density or the resistivity or the chemical composition or a variety of other properties. Really, the core benefit is sort of, inline, multiple critical material property measurements, all in parallel, all in real time.
Gotcha. Nice. So let me reflect back to you and see if I got it right. So
yeah.
You've got the plasma and it interacts with the material, and you've got sensors that measure like the optical emission, so like the light, the spectrum that's sort of given off as you interact with that material, and the thermal characteristics, sort of how hot is it or how does heat dissipate, and then there was electrical, so like is there like an induced change in the current or voltage or something.
Exactly.
And then you take all of that data and you're saying you could interpret it raw, but instead you feed it into a machine learning model which has been trained on certain properties. So it probably can say like, oh yes, this looks like silicon dioxide with some sort of dopant in it or something. You can infer things from it.
Yeah, and it's not to say that we don't use the raw data, right? I mean, we also use the raw data that's like helpful, but it's simultaneously providing all sorts of raw data which people can use, and then also providing these critical material property measurements.
Nice. So you can get information about the material's properties, and then the benefit is multiple at once. So you can measure all the things at once, essentially. And so ultimately then, is that like a benefit for the customer? Is it like a cost optimization thing? Like instead of having to have 5 different tools, you can have one tool?
It's not really that, our core value proposition is measuring certain types of properties in line or non-destructively that otherwise cannot be measured either non-destructively or in line. Yes, so like right now, right, really all these properties that I talk about, they're being measured in manufacturing workflows, but they're being measured by taking, a few samples off the line occasionally and then getting those property measurements.
Gotcha. So it's like every 5 minutes we pull something off and we destructively measure it. And okay, by the way, this one was bad, but the last one wasn't. So for the last 5 minutes, was everything bad? You don't know.
Exactly, right. So then, basically this better real-time information allows manufacturers basically to have more sophisticated and tighter quality and process control. I think it's very easy to think of that in terms of yield improvement, but when you can have tighter quality and process control, you can also make a higher performing product, right? So it's not necessarily about reducing scrap rate, which I think a lot of people, when they first hear about it, they think that's our core value. But I mean, that's part of it, right? But the type of value that I'm most excited about providing is allowing people to really make higher performing products.
So tell me, as you came out of your PhD, you start this company with your professor, you guys raised some money. I'm assuming, you built some prototypes, presumably. And then how are the conversations with early customers?
So I would describe the customer conversations in the following way, right? Is we're never trying to compete with any existing metrology instrument. We're always trying to really provide measurements in types of measurements in certain spots in manufacturing workflows where there basically are zero measurements. So we would always open our conversations up with introducing the technology and then saying, hey, what do you wish you could measure that you currently cannot?
Nice.
Right. And that would get to a decent brainstorming conversation. I think we had a reasonable amount of technical credibility, but also not all the technical credibility in the world. Lots of PhD students work on weird stuff that can never work in industry, right? But the core benefit of making a metrology tool is that it's very easy to try it out and test it.
Nice.
So I think very early on, I was always extremely careful to say, to only say the platform can do what we have shown it exactly can do, right?
Yeah.
And to always sort of lead those early customer conversations to some sort of demo where we say, hey, look, ship us some samples, run them under our metrology tool, right? We'll collect the raw data. We will, make a detailed report about the performance, and then we can take it from there.
Nice.
It's not like testing like the viability or proving the concept for this is particularly sophisticated. In a lot of cases, it's really just send us some samples in an envelope, like seriously, right? We'll see the results. Or in other cases too, right? Because for certain customers with very specific samples, we'll say, or very sensitive samples, we'll say, fine, just come and run it on our campus. That's also fine with us, right? So I say that to say that, despite maybe early and fair sort of skepticism, it was always very easy to prove the concept of the platform.
Sure, that makes sense. And I like how you position what you guys do. Of like, we're going to unlock something new for you. We're not trying to come in and take away business or anything. So and then just give us a chance. Like, well, let us measure the thing and let's go from there.
Exactly, right? Because then I think it's very important to like position ourselves this way, right? Because it's like, there's no benefit for us trying to be a slightly better version of any existing sensor, right? And like, even if we are a slightly better version of an existing sensor, well, that existing company already has a relationship with the other company, right? Like, there's just so much risk involved in switching, right? So we're always just trying to provide new types of measurements in new places.
Nice, that makes sense. So tell me. I guess maybe give us an update on just where you guys are at, like as a company. Raised some money, hired some folks.
Raised some money, we hired some folks. Yeah, I mean, I think that's a fair summary, right? I think at this point, we've now raised about $9.7 million from venture. With most recently we closed like a $6.6 million seed round in July. We now have, I think, a whopping 19 full-time employees.
Nice, nice.
We are basically creating iteratively better versions of our product and releasing those as paying customers. So in the beginning of 2024, we released our quote-unquote alpha units, which were offline units, which are beneficial because even if something sits outside of manufacturing line, just being able to measure multiple property measurements at once with full uniformity maps, like non-destructively, still provides value and it's a sort of stepping stone to our inline tool.
Yeah,
but
builds trust probably with your company too.
Exactly, right? Like, and there's a bunch of benefits here, right? Where it's like, all of the core architecture and hardware and everything in our offline tool is, identical to what would be in the inline tool, right?
Nice.
But no one is going to put a tool inside their manufacturing line unless they've used the offline tool for 6 months to a year, like a lot.
Totally.
And they like it, right? So
so
we released these alpha offline units in early last year, and now we are on the precipice. We think as early as later this month or early next month to release beta versions of those units, which are significantly improved, have a lot more functionality. And we plan to ship these alpha units. We basically made 5 of them. We put 1 in the academic lab. We had 1 do demos in house. We put 3 at paying client sites. Now with these beta units, we're building about 25 of them, and we expect to deploy around 20 to different places in the U.S., Canada, Europe, and Asia. So we're really excited about that.
Nice.
And, a lot of our, it's great. And a lot of our early traction, I would say, was primarily focused in the battery space. And that's because battery manufacturing is really hard and it's new, right? So the argument of hey, do you want more information? But now as we've sort of gained more credibility, right? We've been able to enter other spaces as well, including aerospace, energy generation, like semiconductor, and various types of electronics applications. So I'm also just excited to see how this platform can work for these various other types of industries.
Nice, totally. Yeah, congrats on the beta. That's exciting.
It's taken a while. I thought it was gonna be done much sooner.
I'm sure. Especially if you're building physical systems, I'm sure that a lot can go wrong. You talked about battery industry, and that makes a lot of sense. It's like an easy place to start because it's new and people are hungry for more information. With some of those more mature domains, semiconductors or aerospace, like you mentioned, how do you get your foot in the door there?
Oh, yeah, it's a great question. It's a great question, right? So, I would say our original foot in the door in these sort of more established industries has always come from some sort of warm introduction from someone that we
Nice.
know, right? Either that's like an advisor that we have, or a friend of an advisor, someone that we've met, right? But like even in those industries, particularly in semiconductor, right? Even within that broader space, we're still starting with the newer versions of those technologies, right? Right. For
Gotcha.
example, in like semiconductor, the vast majority of our work has been with gallium nitride, silicon carbide wafers, right? No one has let us touch patterned silicon,
Yeah, totally.
right?
Totally.
Right? So, and not to say that like we won't get there, but in all these things, you see this trend where you have to start with these sort of next generation, newer types of processes where there isn't a lot of information, then you gain credibility and work your way up, right? Even in batteries, actually, we started with next generation batteries, right?
Yes.
And primarily, next generation batteries being made by startup companies who didn't, who were very new, right?
Yeah.
And so I think this general trend I'm sort of seeing in these industries where it's like, okay, you start with something new where people don't have a lot of information, then you gain credibility, and then you sort of work your way in.
Gotcha.
And yeah, that's a long process,
Totally. Oh, for sure. Totally. No, that makes a ton of sense. And I've seen that in my day-to-day life where companies come and they want to sell you on something, but what you have in the process and the product you've built, it's already working, it's already out in the field, you're already maintaining it, like you don't want to touch it. So it makes a ton of sense to say, well, for that next generation thing you're building, what's something awesome that you would want to do but you can't? So for example, like in a different lens, like if an AI ASIC chip is trying to come to my company and say like, oh, buy our chip instead of using NVIDIA, we'd be like, dude, we're using NVIDIA, right?
Yeah.
But if they're like, what if we could give you like 100x the frame rate or 100x the inference, or way lower latency or something, then on the next project, that resonates with me. Then it'd be like, okay,
Exactly.
let's try it because we haven't built the next thing, like why not
Exactly.
experiment? Yeah,
Exactly. Right. Exactly. Right. And,
totally.
And then it's like, if we prove that we're credible there, then, there's ideally opportunities for, the more sort of traditional processes.
Yeah, nice. That makes sense. That's good. So, okay, I know that the Berkeley Skydeck Accelerator is a part of your story. Like, tell our listeners, like, what is that? How did you get hooked up there? What's the benefit?
Yeah, I mean, so I'm a big advocate of Berkeley Skydeck. They were like really, really, helpful to us, right? So, my PhD advisor and I, when we started to, when we started to start our company, we then, asked the question everyone asked, which is, okay, well, how do you fund this, And,
Yeah, totally.
Or like, how do we even, broadly run the company, et cetera, right? And so we applied to Berkeley Skydeck largely I think we just heard about it on like a mailing list or something. We weren't very familiar with it. We weren't very familiar with accelerators like at all. And, we like luckily got in shortly after, I finished my PhD, and they were critical for us for like so many ways, right? Not that I have a great idea how to run a company now, right? But I especially didn't, back then. And so there was a lot of stuff they showed us, just from very basic things about, like logistically and operationally, like what you should do. But like second, they set us up with great advisors who
Nice.
were extremely helpful to us. And then third, the core benefit of Berkeley Skydeck, or not the core benefit, but like one I think unique benefit is they really do just connect you to a lot of people, right?
Nice. Yeah.
So like really a lot. Like so all of our initial clients really were just directly from Berkeley Skydeck Warm intros. Like every single one. In addition to all that, it's an accelerator which wants to have its companies raise a seed round or raise money after, and they're phenomenally helpful with that as well, right? I mean, like raising money and again, not that we're like the most successful company at raising money, right? But it's a complicated and sophisticated landscape, and they really helped us, at least get our feet wet with that and provide us a lot of great advice, through that as well. Had we not gotten into Berkeley Skydeck, we would be on, frankly, a very different trajectory, or maybe different and probably much slower trajectory.
Sure, totally. Nice. So it sounds like they helped give you funding, teach you how to run a company, connect you with customers, connect you with your next round of funding, and help navigate that.
Yeah, and even with the like next round, yeah, exactly. So it's like connecting with the next round of funding, but it's also like really helping us like navigate that, right? And like really also understanding like I think there's a lot of nuance in understanding like what to ask for. Right?
Oh, sure.
Like,
Yeah.
like that's not a trivial problem, right? And at least for us, right, how we raise money, I think a lot of people, or at least the perception I hear from maybe like people just starting a company or whatever, is they think, okay, I have an idea and now I can go like raise a seed round. And it's like, no, that's like, I mean, maybe feel like the best idea ever, right? but at least for us, right, we basically had to raise, like a series of safes over like, an 8-month period before we sort of got enough traction to then justify a seed round.
Okay,
right?
sure, totally.
And there's a lot of strategy in that. It's like, who do you bring to the table? Like, how much do you ask for? How do you best take advantage of the relationships with your investors as well, right? And
sure.
like use their strengths to like help you.
Yeah, that makes sense. Nice. So now you are an example of someone who's transitioned from academia to industry, now starting your own company, getting back into industry. If anyone's listening to this who is currently a PhD student or thinking about that path, do you have any advice on transitioning, looking back now?
Let's see. So, one in general, right? And let's just talk about it from a like a PhD perspective, right? I think the whole point of a PhD is to provide you the tools to solve very open-ended problems. So I actually think that getting a PhD is very helpful for starting a company in the sense that you really are thrown into something that you really don't know anything about, right? And you at least have some tools to attack, or at least not be afraid of these very, very open-ended problems. There's a lot of differences, right? But the big differences to prepare for it, I guess the advice that I would give would be to really think about, if this lifestyle, for lack of a better term, is for you, right? So one, in a PhD, you really get to focus on your research, and you really get to look at problems very in depth and very rigorously, but you don't have to move that quickly, right? In industry, you have to move, much faster. But I think that's an obvious one, right? But at least a big one for me was I was totally unprepared for the amount of external communication that starting a company involved, right?
Sure.
In my PhD, I basically not only talk to my PhD advisor, but it's pretty close, right?
Yeah, totally.
And now I'm talking to God knows how many people a day, right? And even building up the stamina for those types of conversations, or understanding how to use those conversations and how to get the most out of those conversations is sort of complicated, right? So first thing I would say is prepare yourself and think about what is your life if you're talking to tens of people a day, right? And all those conversations can be important. The second thing I would say, and I think actually PhD students are pretty well prepared with this, right? Is benefit of getting a PhD is you live off a PhD stipend for 5-6 years. Right?
Sure, totally.
So you're already trained to not think I'm going to make it big anytime soon, right? So I would also give the advice as well that the patience and persistence required for a PhD also seems very well suited for this type lifestyle to me.
Yeah.
So I would not start this and think, okay, well now I don't have to be patient, now I don't have to do this. It's no, those skills are important.
Nice, totally. So yeah, I can resonate with the open-ended comment you made, where it's a startup, everything is open-ended. The world is your oyster, but you got to go figure it out and do it. And you're saying, PhD students, that's the PhD in a sense too, is solving open-ended things and going and building whatever you need to build, writing papers, discovering what you need to discover to someday graduate.
Exactly right. So I think people talk about in startups all the time, how certain successful companies have pivoted, right, and they've worked on something else. Well, that pivoting action happens in research constantly, right?
Sure, totally. Yes.
You're constantly looking at one thing, and then you think, oh wow, this is interesting. Let me go down this route, right? And
yeah,
so is this an example of a type of thing I think PhD students are sort of well prepared for.
Nice, that makes sense. And then I also resonated when you said basically they have patience and persistence, sort of grit, resilience. As a PhD, you're kind of doing that for 5 years of just pivoting, figuring things out, trying to make it happen, living off of your stipend, and then startup life. It's it's the same thing. You got some good tools in your toolbox.
Yeah.
Totally. The communication piece is interesting too, though, because I think you're hitting on in your PhD, you're probably like mostly scientist, academic researcher. And now all of a sudden there's this other vector that you have to become proficient on, which is like dealing with humans and communicating and,
Yeah, and like communicating concisely and clearly to all sorts of different audiences, right?
There you go, totally.
Like
yeah, not just your fellow colleagues, but also customers, investors.
Exactly, and like each of these audiences requires a different type of communication, right? And there's also interesting aspects too, where how do I say this precisely? These individual audiences like broadly require different types of communications, but then there's also like the best way you can communicate within those broad categories, right? Like,
yeah.
The way I communicate with a customer, I'm not going to use the same words as like someone who's been in that industry for 30 years and is trying to sell them something, etc. Right? Because people are looked at differently, right? So there's a lot of nuance. I think making yourself understandable, for lack of a better term, to a lot of different audiences, and that's hard. I'm still not particularly good at it, right? But it's a constant challenge, right? And yeah, something I hope I can improve at over time.
Sure. Well, hey, you're self-aware. Sounds like you're working on it. That's great. You're in a good place. Totally. Okay, so some like non-SirenOpt, just random questions for you.
Sure.
So I have debates with some of my friends about how much people are actually using, Chat GPT or not. And in your day-to-day life with what you're doing, building a company, like where does LLMs and AI come in for you?
Yeah, so I hate LLMs.
Oh, really?
Let's be honest.
Interesting. Yeah. Tell me more.
All right, so dude, so like, let me. Maybe that was too strong. All right, so
no, that's a great take.
So here's what I'll say. Right. So for SirenOpt, do we use LLMs? No. Right. Are there certain types of neural network based architectures that we have looked at and will look at? Like, yes. Right. But in general, where I stand philosophically is I really, really dislike the trend of just building larger and larger black box models that we throw a lot of data at and we don't really understand the output. Right. I think it's like, we should not be using machine learning to replace all the physics and domain knowledge that we have developed over time. We should be using it to augment the physics and domain knowledge we've built over time.
Sure.
And I think there's a reason why, things like all this power is on LLMs and ChatGPT, et cetera. I think there's a reason why they're constantly being applied to extremely low stakes problems, right? Like writing emails or making a new image or, answering a prompt, I don't know, correctly 25% of the time, right? Right.
Yeah.
So, there's a reason why we don't have some big large language model running a factory. And the fact is, when the stakes are high, you need to be able to guarantee certain types of performance and like understand certain types of generalizability. And so to take this further, like a lot of my PhD research actually was broadly in what can be considered what's called like physics informed machine learning, where I was interested in sort of taking maybe some limited physics knowledge that we had and augmenting that knowledge with machine learning tools.
Gotcha. Yeah.
So
in your products, you will always have a physics informed model that starts with the actual physics and is trained on data and then can make predictions, but it's sort of informed by reality, not just what it inferred from all the YouTube videos out there or something.
Yeah, right. I mean, so like even if we define like people ask like what is machine learning? Well, machine learning is any data-driven model, right? Like a line of best fit is a machine learning model. Right. So we will although our goal is to put progressively more physics in our platform over time, we'll very likely always have some sort of data-driven element, right?
Gotcha.
But outside of that, to this sort of main point here, right? About I don't know how I feel about ChatGPT or how much do we use it, et cetera, or these LLMs, right? They seem to be good to just provide a lot of information quickly that is broadly similar to what you might want to look into. But I don't see large language models or these large neural network models, ever solving extremely complex problems, right, that are important, right? And one last example I'll give, right, is, I think a good example of this is like self-driving cars, right? Like self-driving cars have all the training data in the world, right? I mean, there's no more training data you could give any type of system, and Waymo's still block traffic like 3 times a week in San Francisco, right? So there's just, I think we're gonna the way forward is not to build progressively larger neural network models. It is to see how we can augment what we already know about the world with these powerful tools.
Gotcha. Nice. Thank you for your hot take. I appreciate it. Put you on the hot seat there. That's great. Cool. Well, that's all I had for my questions. Do you have anything else top of mind?
We do have some open positions right now here at SirenOpt. So if you are an electrical engineer with some high voltage experience, or you are a firmware engineer who knows about FPGAs and microcontrollers, please
Nice.
go to our website and apply.
SirenOpt.com.
SirenOpt.com.
There you go.
It's easy. Or on LinkedIn, or email me.
Yeah.
It's easy.
Awesome. Cool. All right. That was awesome. We covered a ton of ground. This is super informative. I look forward to seeing how things go for you.